So, negative exponents have their own special rule. We don't really like negative exponents. Now, what I mean by a negative exponent is if you have, say, x to the negative 4. Your base can be whatever you want, but if you have this negative exponent, there's a rule that we have to follow. Now, what this rule says is that when there are negative exponents, you move the power to the other side of the fraction bar and make the exponent positive. Okay, so if I ever see a negative exponent, kind of like we had up here at the top of the page, we had x to the power negative 4. I'm going to move the power to the other side of the fraction bar. So if it's on the top, I'm putting it on the bottom. If it's on the bottom, I'm going to put it on the top. And then I'm going to make the exponent positive. So let's look at why this might make sense. Okay? If I think about a positive exponent, and they mean that I'm going to multiply. I'm going to take the base times itself, how much ever the exponent says. So I know this fact about positive exponents. Now if I think about negative exponents, and I ask myself, okay, what's the relationship between a positive exponent and a negative exponent? Well, positive and negatives are opposites of each other. So if I think about positive exponents meaning to multiply, negative exponents, if they're the opposite of positive, I need the opposite of multiply. Well, the opposite of multiply would be divide. And I know that division is often represented using a fraction bar, right? So this is why negative exponents moving to the other side of the fraction bar makes sense, because if negatives are the opposites of positives, and I know that positives mean to multiply, well, the opposite of multiply would be divide, so that makes sense that negative exponents would mean to divide, or that negative exponents would mean that I need a fraction. So let's look at what this would look like in terms of a problem. Example number 1, I have x to the negative 6th power. Well, my rule tells me that it needs to move to the other side of the fraction bar. Well, right now, question number 1 doesn't have a fraction bar at all, but remember from when we were talking about slope that I can make a fraction bar by putting the number 1 on the bottom. So, to simplify this, to get rid of my negative exponent, I'm going to take my power and move it to the other side, and then it gets to be positive. So it was on the top, I'm going to move it to the bottom, and I get to make the 6 positive now. Well, since my power moved out of the top, I don't have anything else on the top of my fraction, so I fill it up with the number 1. Let's look at number 2. Again, I see this negative exponent going on, but this time it's already in the bottom of my fraction, so I get to move it to the top now and make my 4 positive. And then again, the bottom of my fraction is now empty, so I get to put a 1 down here. And that really just simplifies to h to the power 4. When I look at number 3, I have 2 negative exponents going on. I have a p to the negative 7, and I have a w to the negative 3. Well, I'm going to have to move both of those. The p, which was on top, is now going to go to the bottom, so that I can make it positive. The w that was on the bottom is now going to go up to the top so that I can make it positive as well. Now that I have all positive exponents, I am all the way simplified. If I look at number 4, I see 1 negative exponent here, so only that power is going to move, and it was on the top, so I'm going to move it to the bottom now. So a to the power 6. But now what do I do with this b to the power 2? Well, since it was positive, I don't have to move it. So it was on the bottom, it's going to stay on the bottom. Well, the top of my fraction ended up empty, so I'm filling that up with the number 1. Now number 5. I see a negative exponent here and down here. So when I think about my final answer, this m to the negative 4 sorry that got erased, but this m to the negative 4 is going to have to move down to the bottom so it can become positive. This k to the 7th that's on the top, since it's already positive, it's going to stay on the top. And then this k to the negative 5, it was negative, so it has to switch sides, so I'm going to take it up to the top and make it positive. Well, I can actually do one more step to this problem. I have two powers with the base of k here. So if I think about, okay, what rule can I use with these two powers? Well, k to the 7th is being multiplied by k to the 5th. So I know when two powers are being multiplied, I add their exponents. So this is going to become k to the 12th, all divided by m to the power 4.